In the previous video, we learned how to use the square root principle to solve quadratics. So we're going to take that concept of the square root principle where you square root both sides, and we're going to use that to develop how to complete the square to solve a quadratic. Now, a lot of students think, because they've told me, right, that their plan is just to not do these, all right, and just take the hit on the test or the homework or whatever. But depending on your course and depending on what you're going to cover, this technique is actually used several places later on in circles and ellipses, in finding the vertex for parabolas in certain formats. So really, you can't just say, I just don't like this, don't want to do it. Okay, because everything you learn in this course actually gets used somewhere else. So you just have to muddle through. Now, there's a specific technique on how to do this. Thank goodness, very clear, very doable. Just do these steps and it works out every time. Okay. And I'm not real sure why students just take an aversion to this, but hopefully you aren't going to be that way. You're going to say, okay, I've got to do this. Let's get it done. All right. And we're going to learn those steps. Now, here we go. This is based on what we did in the previous video where we were square rooting both sides. So I'm just going to kind of remind you about where we were. So we had a problem similar to this. And what we did is we looked at the left-hand side as if the 12 wasn't actually there on the right. And we tried to factor the left-hand side. And you'd say, what multiplies to 9 and adds to 6 since it has a lead coefficient of a 1? Or you could think of it as it has a square on each end, and so that would make it a binomial square. If you said what multiplies to 9 and adds to 6 and a negative 6, it would be x minus 3 times x minus 3, correct? And if you saw it as a binomial square, okay, you would say, what did you square to get x squared? X. What did you square to get 9? 3. And this sign comes in the middle. And these, remember, you had to check. There's in the solving things by factoring, in the description, there's a whole list of individual videos on each individual factoring technique. And this is one of them. Equals 12. All right. Either way you did it. This x minus 3 times x minus 3 is x minus 3 squared. So either way you got there, you got there. All right. Now, this thing that's on the left, this one right there, is a binomial because there's two terms in there and they're squared. So this is called a binomial square. And this square is the one that you're going to complete. And that's the technique. How do I get a binomial square if it isn't already set up to be this? Can I obtain one? Sure. Okay. Now, once you get the binomial square, you're going to do the square root method that we had in the last video, where you square rooted this side, square rooted that side. The square root kind of cancels, undoes, backs up, whatever you want to say, the square. So this is gone. Don't forget your plus or minus. The square root of 12, 12 is not a square, but 4 is in there as a factor. So you'd have x minus 3 is plus or minus. The square root of 4 is 2. The square root of 3 is prime and doesn't have a square. So moving the negative 3 over, you would add 3 to both sides because you do the opposite, remember, of what it's currently doing to get it over there. And that would be the answer, right? Now, the trick here is, can I figure out a general method that has specific steps to complete the square? Because like I said, this comes in very handy in later parts of the course where you're specifically looking for this to use it for something else. All right. So what we're going to do is develop those steps. Now, let's consider this. If you graph this, you would get a parabola, like over here. Okay? And if you set it equal to 0, So in effect, what you're doing is saying, where is y 0? And remember, this is your x-axis. This is your y-axis. So y has to do with how far up and down you're going. So you're saying, I want to go some distance in the x direction, but not any distance up and down. So it would, in effect, be looking for these x-intercepts. Sometimes they're called roots or zeros. So I just want to kind of give you that preview, because when we get to this whole graphing portion of these videos, which is going to be a lot of videos, we'll start talking about zeros, roots, and I'll tie it back to, this is a solution to an equation where it's equal to 0. So just kind of, be aware of that name, roots, zeros, x-intercepts, and then just let it go for right now. All right, I just want you to be aware. And what we're going to do, I'm going to rearrange this just a little bit, is just solve this equation for what x's that you could use that would give you a solution of 0. And we're going to do it by completing the square. All right. Now I just need you to just sort of maybe follow along and just sort of listen to what it is that I'm saying. Then I'm going to say, okay, is this the steps that you heard? And then we're going to fine tune the steps as we go along. So remember, that's how you survive your math class. Okay, listen to what your teacher's saying, because what they say is what you have to think so that you can do what it is the process wants, right? So what they say is your list of steps. And I'll be honest, most people are not auditory learners, right? We hear something that goes right out of your head, right? So you have to write down what they're saying and then modify it as you go along. All right, so here we go. Now, generally the quadratic form, remember the kind of standard one or generic one, is that a is the number that multiplies the x squared term, b is the number that multiplies the x term, and c is a constant. All right, so just remember a, b, and c. So in our case, a is 1, and understood 1, b is 4, and c is -6. Okay, now here we go. So look at this, and what we're going to do is look at it and go, oh, complete the square. Okay, first thing, it has to have a lead coefficient of a 1, because we can only complete the square on something at this moment if it has a lead coefficient of a 1. We're going to find out a slightly different variation of this later in the course. All right, then you move the constant to the other side, leaving a little workspace to work in. All right, so what's the first step? It has to have a lead coefficient of a 1. All right, so to complete the square, if I could spell, okay, the first thing is it has to have a lead coefficient of 1. And I'll work a couple that don't have that. All right, then you move the constant to the other side, leaving all your variable terms on the other, one side, constant on the other side. Okay, and you leave kind of a little workspace. All right, now, so we've done that. All right, then you take half of the b. Okay, now b is just the number, the coefficient that multiplies the x. You take half of b, okay, and show it squared. You can square it, but it just makes you have to undo it if you actually square it. Okay, I'll show you in a minute what that means. All right, so we're going to take half of b. Now b is 4, and half of b is 2. Okay, so we have our x squared plus 4x. And in this workspace right here, we're going to take the 2 and say we're going to square it. All right, and then what you do to one side, you have to do to the other side. Agreed? You doing okay? All right, now this right here, is always a plus. Because if you remember from binomial squares, okay, when you multiply them out, if you have something like x minus 3 times x minus 3, it's x squared minus 6x plus 9. If you have x plus 3 times x plus 3, it's x squared plus 6x plus 9. So this is always positive, all right? So this is always going to be positive right there. All right, now this right here actually completes the square, but you haven't shown it to me yet. So this step wasn't that hard, was it? You take half of b, you say you're going to square it, you put it in this little workspace right here, all right? That completes the square, and what you do to one side, you do to the other, all right? And then you're going to show me the binomial square. So you're going to show me this binomial square, all right? So what happens is this x comes down. This sign right here comes down. If it's plus, it comes down as a plus. If it's a minus, it comes down as a minus. And this 2 without the square comes down. So the x comes down, the plus comes down, and the 2 without the square comes down because you've got this square out here, right? Okay, so you would have the x comes down, the plus comes down, the 2 comes down. If you had said it was 4, you don't bring a 4 down. You would have to square root it and then bring it down. So you would square it and then unsquare it, which just sort of makes you do twice the amount of work. So I always suggest that just don't actually square it. Just show you're going to square it because you only need the unsquared number to come down. Okay, equals. Now on the right side, you want to go ahead and square that so that you can add it. Okay, you doing all right? Now, this step right here is where you completed the square. And this step right here is where you showed me the square, binomial square, right? So let's go over here for a second and let's think about our list. So you took half of b and you show it squared and you add it to both sides. Okay? Then you show the binomial square on the left. Now you may need to make a little note here as to where do you get these parts. Okay, so the part that's in the parentheses, you need to make a little note that makes sense to you about what parts right here are coming down, right? Then you simplify the right-hand side, and we're going to use RHS for right-hand side. Okay, so that's where we are right now, right? Then you're going to use the square root principle. And that's going to take you back to the steps that you learned from the previous video about what to do there, right? So you okay? So we square root both sides. The square root of x plus 2 squared is x plus 2. Don't forget your plus or minus, okay? That's the key. You might even want to put that in a different color or star it or whatever. Don't forget the plus or minus, and you have the square root of 10. Now 10 is not a square. It doesn't have a square in it as a factor. It's 1 and 10, 2 and 5. So it's just stuck. But we want to move the 2 over, so we subtract 2 from both sides. And it looks like this. Now this is an exact answer. Doesn't make any sense to me about what it is really. I mean, you can sit there and go, let's see, the square root of 10 is probably a little bit over 3. So negative 2 plus a little over 3 is probably a little over 1. Okay, negative 2 minus a little over 3 is probably a little over negative 5. But, I don't really have a gut instinct for what that number is. But if you run it on the calculator, you get 1.162 and minus 5.162. This is an approximate value. So if they don't ask you to approximate the answer, then it's assumed that you're going to leave it exact. All right? So this is the exact answer. That's approximate. And you remember that little parabola that I showed you? If you look right here, here's the minus 5.162. Here's the 1.162, which is where it crosses the x-axis, right? Okay. Now we have this potential little list of steps there. Let's see if it works again. And that's what you do with your list. You start off with kind of an approximate list, and then you do 3 or 4 or 5 problems. Don't do all easy ones. Okay, do an easy one, a middle one, a couple of hard ones. And if the list still works and you haven't missed anything, then you got a good list. And that's what you memorize, and you memorize the list for your test. You don't practice problems over and over without the list, okay, because you won't have a pattern on the test. So here's my new problem. It says solve this by completing the square. And you go, oh, completing square. I got this. Totally got this. Okay, it has to have a lead coefficient of a 1. Oh, I don't got that. Okay, so here we go. So how do I get a 1 from a 2? You're going to divide. Okay, so that's fair. You can divide this by 2 as long as you divide everybody on both sides by 2. So you're going to divide all the way across by 2. And that would leave you x squared minus 6x plus 13 equals 0. Okay? All right. Now, so I got my lead coefficient of a 1. Now I move the constant to the other side, leaving a little workspace. All right. Then I take half of b. Now what is b? b is a negative 6. Okay, now I don't actually need the negative 6 because the sign is going to take care of itself. So all I really need is the number, all right? So I suggest that you don't write down fully what b is. You just need the absolute value b in a sense. Okay, you just need the number, not the sign. Okay, so half of 6 is 3, right? So this is going to be a 3 as soon as my computer unfreezes. All right, so it's 3. So then we're going to, this is always a plus, we're going to take the 3 and say we're going to square it. And what we do to one side, we have to do to the other side. So here we go. You have completed the square. You just need to show it to me. So this x comes down without the square. This sign comes down. This 3 comes down without the square. Because you've got your square on the outside of the binomial. Equals. And you have minus 13 plus, and this side you actually square out, plus 9. So you have x minus 3 squared equals minus 4. Then you're going to apply the square root principle. And the square root of x minus 3 squared is x minus 3. Don't forget your plus or minus. And the square root of negative 4 is the square root of 4 times a negative 1. The square root of 4 is 2. And the square root of negative 1 is an I by definition. So x is 3 plus or minus 2i. If you ever get anything normal, I say normal. Okay. Shouldn't say things like that. Okay, if you ever get anything that's like rational numbers like x is equal to 3 and 3/4 or something like that, that just says you could have factored it before you went through all this process. So it sort of relieves me to have something like with imaginary numbers or square roots in it, because that makes me feel like, okay, I chose the right technique if you're ever given options. All right, so let's try another one. So what if you have x squared minus 3 equals x? Because sometimes, they're just all jumbled up. So, well, we go, well, and if we're going to complete the square, it has a lead coefficient of a 1, but I need it to be, with my x's on one side and moving my constant to the other side. So it would look like this, right? So we rearrange it. Now, b is actually 1 because we don't really care about what it's a -1 or a +1. We just need the actual number. So half of 1 is a half, right? So we're going to take that number, put it right here, and say we're going to square it. And what we do to one side, we do to the other side. All right. Now we've completed this square. We're going to bring our pieces down. There's my square. The x comes down. This minus sign comes down. This 1/2 comes down. And this is 3 plus. Now this whole 1/2 is squared, so it's 1/4. Now we have 3 over 1, and we need to add it to fourths, so we have to have a common denominator. So it's 12/4. So this is 12/4 plus 1/4. This is 13/4. All right. Then we're going to square root both sides because that's our list. Remember, we're just running through our list. The square root of x minus 1 squared is x minus 1. Don't forget the plus or minus, so don't get busy cleaning that up before you put the plus or minus down. And you would have the square root of 13 over the square root of 4. Square root of 13 is prime and it doesn't reduce. Square root of 4 is 2. I switched the 1/2 to a 1. Don't know why. I hope y'all caught that on the way by. Alrighty. So x equals 1/2 plus or minus the square root of 13 over 2. Now some computer programs and right, some computer programs I just had to double check. I want to look up there and make sure I didn't lose a sign somewhere. All right, so some computer programs want it written separately as little fractions like that, and some teachers and some computer programs want it written with your common denominator. I actually prefer it this way. Okay, but you know, whatever your teacher wants is the way you're going to do it. All right, one more problem. What if you have 4x squared minus 6x plus 12 equals 0? All right, so then what you would do is divide everybody by 4. And you would have x squared minus. Now 6/4 reduces to 3/2. X plus 3 equals 0. So sometimes you don't get nice, clean integer b's, okay? And that's all right, okay? You're tough. You're in algebra. You can do this, all right? So we're going to complete the square. We move the constant over, leaving a little workspace, all right? And then we're going to take half of 3/2. Remember, we don't care if it's a -3/2. We just want the 3/2. So half of 3/2 is 3/4. So if you will actually take the time to write that down and show you're going to multiply by a half, because half of means half times, then that will reduce a little stress on, oh my gosh, what am I going to do with that fraction? Okay. So then we say we're going to put this in our workspace and say we're going to square it. All right. So then we've completed the square. We're going to show it. So the x comes down, this minus comes down, and this 3/4 comes down. I was looking to see if everybody I did was a minus, but the very first one was a plus. So remember, whatever sign that is, it's going to come down. So if this is a minus, it comes down as a minus. If it was a plus, you'd bring down a plus. Okay, equals minus 3 plus 9/16. All right, so minus 3 over 1, and I need 16ths, is minus 48/16. So this is minus 48/16 plus 9/16. This is minus 39/16. All right, almost done. So now we complete this sort of process by going over to the square root both sides. So the square root of x minus 3/4 squared is x minus 3/4 equals. Don't forget the plus or minus. And you have the square root of 39 times a negative 1 over the square root of 16. So x minus 3/4 is plus or minus the square root of 39. Okay, now 39 is 3 times 13. That doesn't help. They're both prime and neither one's a square. And 39 is not a square. But the square root of negative 1 is an I. And the square root of 16 is 4. So you have x is 3/4 plus or minus the square root of 39 over 4i. Now, let's talk about this. All right. It could also be written as 3 plus or minus the square root of 39i over 4. Now, I want you to look right here because I've intentionally written it even a little bit more messy than what I'm normally doing. Keep in mind that this is the square root of 39 and I has been pulled out, okay? It should not be up to the teacher to decide if that I is under the square root or not, okay? So be sure that if you're going to write the I next to the 39, that it's an I. And sometimes I see people putting like a little hook right here that says, you know, that's the end of my square root, and that's fine. Absolutely helps me to deal with it too. But be sure that the I is not underneath the square root. Okay, and that's the answer to this one. Alrighty, I hope that helps. Don't forget that in the description there's practice problems for you to do and complete worked out solutions. And so here's the steps. You get a lead coefficient of a 1. Let's go back here so you can look. Okay, you get a lead coefficient of a 1 if it doesn't already have one. You move the constant to the other side, leaving a little workspace. You take half of b and you put it right here, saying you're going to square it. And what you do to one side, you do to the other side. Then this x comes down. This sign comes down. This number without the square comes down. And you simplify the right-hand side. Then after you do all this simplification right here, you're going to square root both sides. Okay, go through that list of steps. Don't forget your plus or minus, and then clean up both sides and you're done. All right? And what we're going to do is in the next video, we're going to use this completing the square process to develop our very own quadratic formula. All right? Which is the same that everybody else uses, but I swear you should know how to derive this. All right? So we're going to start off with that, and then we're going to use the quadratic formula, which works on all the ones that have squares on it, whether they factor or not. Okay? And that'll be the end of this one.